in problem 3, we need to evaluate a limit here of a relatively complicated function. And it's one that is indeterminate if we plug in 0. And let me show you why that's the case. If we plug in 0 for x, our term absolute value of x is definitely just 0. But in our trig function, we encounter a problem because 2 divided by 0, first of all, is an undefined term. It's going to give us either positive or negative infinity, depending on which side of 0 we come from. But the problem is that sine of an infinite value, whether it's positive or negative, is indeterminate because sine always just oscillates forever. So this is kind of a different type of indeterminate form than you might be used to for most of the problems. When you have a trig function like this is indeterminate, and we really don't have any way of simplifying that. We don't have a way of canceling anything out. So the way that you solve a problem like this is you have to use the squeeze theorem. So when you use the squeeze theorem for a limit problem like this, your first step is always to use the trig function by itself and set it up in a proper inequality. So we start with sine of 2 over x, and we know that sine of anything is always bounded above by 1 and below by negative 1. So this inequality is true regardless of what's in the middle, or what you're taking the sine of, what the argument of the sine is. So what we can do is we want to get our original function up here to be in the middle of this inequality so we can try to apply the squeeze theorem. So in order to make this look like our original, we'd have to multiply everything by absolute value of x. So by doing that, we would get the following. So I just took this inequality and multiplied everything by absolute value of x. Note that we don't have to change the signs on the inequality or anything because what we multiplied by is positive. So now we get our original function in the center. So let's think of it this way. We're trying to take the limit as x approaches 0 here, but we can't plug it in and just figure it out. But if we took the limit as x goes to 0 of this, the right side of this inequality, and the left side, that could tell us what our limit has to be between. So what we're going to do now is we're going to do the limit as x approaches 0 of the whole thing. But for our end functions, negative absolute value of x and absolute value of x, that becomes pretty simple because those are not indeterminate and we can just plug in 0. And to both of those, if we plug in 0, we actually just get 0. So our next part of our inequality then becomes this. So to go from this line to this line, what we did is we did limit as x approaches 0 to every part of that inequality. So the limit as x approaches 0 of this is 0, and the limit as x approaches 0 of this is 0. So that tells us that the limit as x approaches 0 of our main function, absolute value of x sine of 2 over x, has to be less than or equal to 0 and also greater than or equal to 0. And if that's the case, then that means it's equal to 0.
The Teaching Center, UF's Learning Resource Center.